Okay, once again, our objective is I can model linear relationships, and we already, like I said, we saw a lot of this this year, and we're going to put this one together to make sure we are understanding what we're looking at, okay? So to get us started, I'm going to go ahead and first send you the screen for the home plate for today. Copy the table and copy the steps. What's that? I know, hold on. All right, it should be on your screen right now. Do you see it? Okay, notice the table, it has 3 columns. It has a student column, it says student A, B, C, D, and F, and G, I'm sorry. And then it says the middle column, time studying for a test in hours, 0.50, 4, 2, 5, 1, 3, and 4. And then test scores in percent. Then we have 20, 80, 40, 95, 30, 50, and 85. Copy that table on your paper, please. Copy the table on your paper, please. And once you're done copying the table, look at the steps to the right of that. It says, number 1, plot the data on a graph. Number 2, sketch a line that best fits the data. Number 3, find the slope of the line or for the line. What does the slope mean? Number 4, write an equation for the line. Bless you. Number 5, predict the test scores for someone that studies 6 hours. And number 6, if we include the following data, will it change the model? Student for part A, it says student H is studied 0.25 hours, and the test score was 75, and student I studied 0 minutes or 0 hours, and the test score was 70. So copy that, and that's going to be for your home plate for tonight. All right, here we go. So going back to the previous screen. So like I said, we're going to go through a linear relationship. You already have your home plate. You're going to keep that, right? Now, let me show you an example that we already covered, and I left this for home play a long time ago. I think it was in Thanksgiving or Christmas break. And it looks something like this. It says, heartbeats. In this task, you will use data to create a model that shows the relationship between an animal body weight and the pulse rate measures. Then you will examine additional data to evaluate your model. So it says here, a study states that the relationship between an animal's pulse rate and the body weight is approximately linear. The word linear means that it makes a straight line. So here's the information that they give us, and look what happens right after. Once they give you that, they're going to plot the points onto a graph. Look at it. So here, this one is 3, 130. 3 is about right here. 130 is up here, so there's my first point. The second point is 2875. 2875 is about right there. The next point is 5675. 5675. The next one is 192.95. 192 is close to 200, and 95 is close to 100, so there it is. Does everybody see all the points? Yes. It's on your screen, right? Okay. So they've been plotting all the points. Does everybody see that? Okay. Now, there is a straight line that can fit in the pattern of the direction of those points. Now notice the direction. If we're going from left to right, notice in which direction all these points are going. Does everybody see that? Okay, so I'm going to send you this screen to your iPad. I want you to lock your toolbar, and I want you to draw a line that you think best fits the direction that this is going. But make sure it's going through the center of that data. Ready? All right, I'm going to do that right now. Give me a second. All right, so now that I showed you some of yours, let me show you what they mean by best fit line. Here it goes. Look up to the screen, please. So watch. Here's my graph. I need to draw a line that follows the pattern of these points. Necesito dibujar una línea que sigue el patrón de estos puntos. Okay? Now check this out. Let me show you what is not a best fit line. Is that following the pattern? No, because there are no points up here, and it doesn't end here. The points are way over here and down here. So let me move it to make it look a little bit more close to the pattern. Bring this down about right there, and bring this over in that direction. Look at it. Does that come pretty close? Yes. Now let me show you why it comes pretty close. Look up to the screen. It comes pretty close because it's right in the center of all the points. Esta sí, sí se puede tomar como que está un poquito más al centro de los puntos porque está en medio de todos los puntos. Now check this out. How many points are above this line? 3. How many are below? No. 3. Look, 1, 2, 3 above, 1, 2, 3 below, and I'm going through 1 point. So notice that it's very centered. Does everybody see that? That's a best fit line. Now, why do we need it to be best fit? Because look at the next question. Look up to the screen, please. Look up to the screen. Check this out. Look at the next question that they're going to ask. What is the equation of the line you drew in item 1? Copy that question, please, on your paper. What is the equation of the line you drew in item 1? What is the equation of the line you drew in item 1? Copy the question, please, on your paper. So, let's see, refresher for some of us. We already covered how to write a line. And who remembers this? Because the first thing that you see when it says, what is the equation of the line? Lo primero cuando pregunte qué es la ecuación de la línea is you should write, bless you, you should write y equals mx plus b. Who remembers this? Yes, it's the lesson we already covered, right? So check this out. This is the slope, and this is the y-intercept. So now that we have this, we need to write our equation. Y equals blank x blank. All right? So this last part is the y-intercept, which means where the line intersects the y-axis. Esta es la intercepción Y, donde la línea intercepta la Y, la línea Y. So here we go. Let me go back. Look at this one. Look up. Look at the line. This is my y-axis. Tell your neighbor, what is the y-intercept? What is the y-intercept? Tell your neighbor, please, what is the y-intercept? Who said 100? I'll take 100 because it's pretty close. Is that correct? Bless you. So let me so you can see it. It's about right. 100 is right here. Do you see how that's going to hit right there? So on our equation, where does that go? The y-intercept goes at the end, so you put plus 100. Are we there so far? Okay. Next, what else do we need? The slope. Make a note for yourself. This is, once again, you already know how to do all this. To find the slope, which is m, we need to find the rise over run. Who remembers that already? Yeah, right? So to find the rise over run, we need to pick how many points? 2 points. So let me go back to the graph. Going back to the graph, let's see. I need to pick 2 points. that are on the line. Let me zoom in for those of you that can't see from back there. Here it goes. I'm going to pick, let's see. I'm going to pick this point, and I'm going to pick this point. Everybody see those? So watch. From here to here, it's 100. From here to here is 50. So each one of these has to be at least 15. 16 or 15, right? I'm going to leave it at 15 for right now. Yes? So watch. So going from here to here, you guys remember when I introduced slope? I told the lady to go from the high school to Frank Wright, right? We don't go straight through homes like that. We go steps down or up. Is that correct? So let's see how many steps down do we take. 1, 2, 3, 4. And is that right on that point? Yes. And each one is 15. So what is 4 times 15? 60. And since we went down, it's a negative 60. Are we there? Now from here to here, what is the run? From here to here, what is the run? From here to here, how many steps this way? 600 steps. So the run is 600. Everybody see that? Therefore, my slope is, rise over run, which is negative 60 over 600. Can I reduce that fraction before I write it in my equation? Yes, I'm going to get rid of some zeros. Look up. This 0 right there. So we're left with 6 over 60. What can I divide top and bottom? Divide by 6, so we're left with negative 1 over 10. Now we can write that in our equation. Let me go to the equation. Negative 1 over 10. So my equation is y equals negative 110x plus 100. Are we there? All right, so now check this out. What does the slope mean? That's what they're asking us to look at. What does the slope mean? So look at the entire problem. Look it up, please. Look up. The x says average body weight, and it goes from 0 to 600. And the y is the beats per minute, and it goes from 0 to 300. But look at the direction it's going. What does the slope mean according to this? Talk it over with your neighbor. What does the slope mean if it's going in that direction? Talk it over, please. Si está yendo la línea de aquí para acá y esto dice que es peso de un animal en kilos y acá dice el pulso del animal en por minuto, ¿qué son? ¿Qué quiere decir el pendiente? ¿Qué es lo que nos está diciendo la gráfica? Yeah? Okay, let's see. Nisa, how can we generalize what the slope is telling us? That what's that? The pulse rate decreases when what? Okay. When the weight goes down? Let's see. We start at 0. Or when the weight goes up. Did everybody hear that? The pulse rate lowers when the weight goes up. So the heavier the animal, guess what? The less pulses. Everybody see that? Okay. So now that we understand what this is saying, let's go to our equation. Look at our slope of the equation. What does this mean specifically? Talk it over with your neighbor. Talk it over with your neighbor. What does this mean specifically? Let's see, help us out, Brian. Okay. What was the run? No, what was the run when we first found the slope? The run was what? And what does that represent? Okay, so let's go back to our equation. What is the run? 10. So what does that represent? That for every 10 kilograms of weight, what happens to the animal? By 1, less or minus 1 pulse per minute. So every 10 kilograms that they gain, they reduce their pulse rate by how much? By 1 beat. Does that make sense? All right. So look at the last question. Interpret the slope of the line for item 1 in context of the situation. So we already did that, and we got that, and we're done. Let's go to the next situation. Look up. Based on the equation, let me write my equation. You don't have to write this down. Just pay attention. Y equals negative 1/10 x plus 100. Based on the equation from item 2, predict the average pulse rate for an animal that weighs 6 dozen kilograms. Now, what are we going to do with this number? Do we substitute into the y, or do we substitute into the x? And why? Talk it over with your neighbor. Which one and why are you going to substitute in there? Go. Let me go back to the graph so that you guys can see that, and maybe that helps you out. All right, help us out, James. Which one? The y? Okay. Let's find out. This says 6,000 kilograms, which is weight. Let me go to my graph. Where's the y-axis? Here. What does that represent? Beats per minute. So do we substitute into the y? No. What does the x represent? The body weight. So in our equation, where are we going to substitute the kilograms? In the x, because it represents the kilogram, which is the weight. You see what we're saying? Okay. So for home plate tonight, when you get to this part, notice what is the only thing I didn't give you? The graph, which means what are you going to do? Make a graph. Plot your points. Once you plot your points, what do you need to draw? A line. From there, you're gonna write an equation for the line, including the slope, and answer the questions as you go through the questions. Yes? All right. I'll stop right there. So this is for home play for tonight. Enjoy your home play.